purpose of this film is to conduct AD 7713-21, and we'll be using Piper Service Letter 782B to perform the 1,000-hour gear inspection, parts A and B. At the same time, we'll also be looking at AD 97-01-01 Rev 1, which involves the pivot point on the landing gear. So we'll be doing both of these at the same time.
My name is George Mahurin, and I'll be assisting Hans with this informative video. I'm an A&P and an IA, and what we'll be doing is going through the different steps for the 1,000-hour landing gear inspection.
Okay, we have the airplane up in the air, and before we start tearing it apart, George is going to show us how to perform an annual inspection on the landing gear in the down and lock position.
Now what I'll do is I'll give you basically what the service manual tells you, and that is to inspect the wheel assembly itself and the tires for cuts and broken areas, inspect the disc and the brakes for clearance and wear. There is a definite wear pattern that will set up on the discs themselves that you have to watch for. Also, you want to look at all of your strut assemblies, make sure they're not leaking, make sure that the assembly is tight and no play in and out, and visually inspect the entire landing gear for wear, cuts, leaks, and so on. Before you jack the aircraft, obviously you're going to check for strut extension to make sure that it's where it should be, and if it's not, you're supposed to service it before you put it up on jacks so that when you do your retracts and so on, everything is as it should be if you were going to do it anyway. Okay, now when you're playing with the nose gear, it's not a different set of rules, but there are specific other things that you want to look at. Obviously, you want to look to make sure that the wheel is tight, it rotates properly, no cuts or abrasions, the wheels themselves are not broken, the bearings are free. You'll take the bearings out, repack them if necessary, put it all back together. Strut for extension. You also want to make sure that there are not a whole lot of rock chips or anything like that out of the strut. Those can be dressed out. You want to make sure that the scissors are right. One of the things that you really want to look at, though, is up in here. You can't see it from your perspective, but up in here is where the steering belt crank is. You're supposed to check for freedom of movement, and of course you don't want a lot of slop. If you have a lot of slop, then that'll give you a shimmy. It tears up your nose gear, and of course tears up all of the bushings that are up inside, making it difficult for the airplane to actually do what you want it to. The other things that you look at would be all of your mechanisms to make sure everything's good and tight and solid. You want to inspect for cracks, as always, and anything that looks deformed. Deformities can actually come in a number of different viewpoints, for lack of better terms. You can see where things are not quite right. If if you're looking at a flat surface and you can see where it's been detented one way or another, that's a problem. And basically that's what you do for the nose gear. And of course, for all of the gear, when you're done doing the physical inspection, you go ahead and grease it as necessary. You'll run the gear up and down. Then you'll do your emergency extend and make sure that all of those things are functioning properly. And then, of course, place the aircraft back down on jacks. Sometime during the inspection, what will happen is that the inspector is going to ask to or have to do a gear retract. In doing that, he'll, of course, position himself down here where he can see what's happening as the gear goes up, and he's going to watch for things. Some of them are going to seem kind of stupid and simple, like, okay, is there clearance for all of the mechanism as it goes up? Is anything chafing? Is anything rubbing? The wheels, make sure that they're clearing. Believe it or not, sometimes you can put too large of a wheel or a tire on it, and although it'll be good on ground, when you get in the air, it grows and will hang up and you can't get the gear down, which is not a good thing. Another thing you might want to pay attention to, and that is this unit right here, that is the linkage to retract the landing gear door, because if it gets out of alignment, it can literally break the ends off of the push-pull rod here, okay, or the connecting rod, and therefore making it a problem for when your gear goes up and down. So you need to make sure that this is in alignment with the strut straight front to back. With that, we'll go ahead and start running the gear up. If you would do so, I'm clear of the gear. Once the gear's up inside the hole, you want to make sure that there is not a whole lot of freedom of movement of the gear itself, because the air movement actually has a tendency to try and draw it back down out of the hole. As it's up there and locked into place, you go ahead and you check to make sure that your gear doors are not coming down into the wind stream. And what you'll do is, one of the tests that you can do is, we have here the combination of these 4 items is 9 pounds. And what we'll do is, we'll set it up in here, and this is to check the tension to make sure that the door is properly rigged. We put this in here, we tighten it down just enough. We aren't trying to remake anything, just secure it, and then hang our weight on the end of it. And we check for a 1/4 inch of or 1/8 inch of clearance right in this area right here. If it doesn't fall down any further than that, this is properly rigged. If it falls down further than that, then of course this rod end needs to be adjusted to draw the door up in a little bit further. But that's about normal right there for that particular test. And of course, then we would roll over to the other gear and do the same thing over there before we had the gear extended again.
Okay, we're flying along at our cruise altitude, and we're finding out as we come into the pattern, we can't get our landing gear down. What are some of the reasons? Maybe you forgot to turn on the field switches, and you ran the battery down. Perhaps another reason is the circuit breaker itself. No matter what happens, you're in a situation where you need to get the landing gear down manually. So what we're going to do is demonstrate that for you right now. First thing I'm going to do is take my flight bag, put it underneath my legs like that. Loosen up the shoulder harness a little bit. Check to make the circuit breaker for the landing gear motor is not popped. I'm going to take off the plate. If you forgot how to do it, here's the instructions. Okay? Up to this point in time, you want to maintain your landing pattern speed. Pull out the emergency gear handle. You want to put it in and a twist. You want to extend that out. And now we're ready to lower the gear. Before we do that though, here's the motor. Here is the brake that stops the motor from turning when the power is off. There's a worm drive in the transmission that runs the jack screw, which pushes this up, and it connects to the landing gear arm right there. When I lift this handle, This black part will move forward, and this landing gear arm will rotate back. When you're in the air, you need to be at about 100 miles an hour indicated in order to get a good, clean gear extension. So up to this point in time, maintain your pattern speed, and when you're ready to lower the gear, reduce your speed, and then proceed to do it. When we're on jacks, we have no air resistance on the nose gear and on the main gear doors. So for that reason, we want to be very careful that when we do it on jacks, we restrain it and don't let it fall. Okay? So, reduce the shoulder harness a little bit more. It is now done and locked. Okay? As a matter of fact, a little bit of effort, I can actually raise the gear and lower it. Like that. This is out of the way. It's good and solid. You're now prepared to make your landing. Reduce your power and proceed with your normal landing as you would under normal conditions. Well, we got all the seats out now, and while George was getting all the panels out from underneath, I took out the interior and put everything off to the side here. So let's take a look inside and just see what has to come out of the airplane. And here we have the floorboards are out, seats are out, everything is exposed. And in the front part of the cabin, we have the center floorboard comes out, the dog dish comes out. We're exposing the fuel selector valves, the boost pumps, and of course the gear itself, the gear motor. I thought I would follow up on some of the features that we did when we lowered the gear manually. A couple of things. One, Service Letter 447 talks about the retract spring on the gear motor. It is required and it is necessary to get the gear motor arm out of the way when you do a manual extension. Let me show you the spring. It is this spring right there. And yes, it is held in place with that cotter key. What happens is that spring brings the motor up, pops it up. Another thing, you want to be sure that that slides smoothly. Another thing, the ball screw retainer has to be dimpled in order to hold it. You don't want this to spin. When the motor is operating, and it's in the either up or down position, but when it's operating, you don't want this ball screw to be wobbling. What that means is the ball bearings that are inside this area right here are worn out. This is your up limit switch. This is the solenoid that operates the gear. If you're having trouble with hesitation of the motor when the gear is operating, you may want to double check all of your connections here to make sure they're corrosion free. Staking of the sleeve here is done per service letter 650. And of course we're doing the 1,000 hour gear AD per service letter 782B, which among other things requires 2 springs to be on the nose gear. That's for singles and twins. And lastly, third over from the right is the circuit breaker that controls this solenoid. The furthest right on the top right circuit breaker is for the motor. Now, on the singles, all there exists is a little flapper door here, which allows you a chance to pull the red handle. On the twins and the later model singles, of course, we see everything here. It's all exposed. I'm wondering how many people, when they do their annual inspection, take this area of the floorboard out to watch this motor operate, to make sure that the jack screw is going out smoothly, adjustment of the up limit switch is done. This can be a very servicing of the motor here and watching it operate is very important to maintaining a robustness in the gear itself. When you saw me do the manual extend, I was sitting in the chair, seatbelt on, shoulder harness on, and it was necessary for me to use 2 hands. One to lift the arm up, and the other one to restrain the gear from coming down while it's on jacks. In flight, again, maintain your airspeed. Put this handle in place first, get it positioned and locked. One hand, you can pull this up, and the gear will partly extend. At that point in time, reduce your airspeed to 100 miles an hour indicated, and the gear will go over center almost immediately. If you're going to be doing this VFR, remember, you're leaning down. You always want to be sure that you're flying the airplane first. If you're IFR, it's going to be, you're going to have to pay attention to your flying.
Okay, to keep from boring you to tears, watch me take this apart. I've gone ahead and disconnected quite a bit of what's going to have to come out of here for this particular section of the inspection. This isn't dealing with the 1,000-hour inspection. And what I've done is I've disconnected the brakes. I've clamped them so that we don't end up spitting the pucks out as it sits here, because just the head pressure will do that. I went ahead and disconnected this clamp, which fastens it onto the strut itself. And I'll go ahead and take this and move it out of my way, just like this. I disconnected the door because I'm taking this whole section out of here. Another thing I've done, I went ahead and off of our retract link, I took the switch, and this is the down lock switch, and I move it up out of my way like that so it's clear. I want to make sure I don't damage any of this electrical wiring when I pull this down. The next thing I'm going to do is, on this swing arm, there's a retract spring that needs to come out, and I need to disconnect this from the push-pull rod that's up in here that actually moves all of this linkage. So I've disconnected another nut right in this area here, and when I pull it out, you'll see this whole gear will become loose, and I can move it around now. And as I do that, then I'll swing it down out of my way and go ahead and disconnect this bolt that I need out of here. All right, earlier on I said I had removed this switch, and the reason I'm doing it again is so you can see the standoff for it. And what happens is when the gear comes down locked, this lever comes down and pushes this switch, and that's what gives you the indication of down and locked. I'm going to go ahead and move that out of the way once again. This is the push-pull rod I was talking about. This is actually the business end that makes this move when the motor moves the push-pull rods. Because I need this out of here, I'm going to go ahead and push this bolt out, which frees up the gear. I showed that earlier. That way I can basically break it so I have clearance to move this out of my way. Once I get that spring off of it. Pause it. There we go. And oftentimes this will be a difficult little venture. There it is. Because if you let it go, you destroy stuff. Then get it out of my way. Now, this whole link I'm taking out because in the 1,000-hour inspection, we're worried about all of these clearances and settings down here. So the next thing I'm going to do, I've got my gear door disconnected, I have my linkage disconnected, and now I'm going to go ahead and take there's 8 bolts that hold these supports in so I can bring the whole trunnion out. One other thing I'd like to do, and that's to tell you that the bungee cord, which lives right there, in this particular instance, you can just roll it off if you want, or you can use a special tool to take it off so that you can reuse it. And move my light around a little bit here. Okay, just as a note, I've left the main gear on this, the main wheel on this, because I like to have the girth to mess with the whole time I'm pulling this out of here. You'll notice as I move it around that the bungee and the spring arm is right here. And another thing that you want to make sure that happens is that this roller will actually rotate when this moves around. It doesn't look like this one's really doing that right now, but we'll rectify that before we're over and done with it. As I said earlier, you can go ahead and roll the bungees off. And what I'll do is, because it's easier for me to do it from here, you may not be able to see the bungee right up in here, but if I grab it, I can literally roll it off of there without having it damage anything. It makes a tremendous amount of noise, but it doesn't hurt anything inside the aircraft. And if my hand is out of the way, and it should be, then it won't break my hand either. Okay, we went ahead and shut things down long enough to go ahead and loosen this up, get it ready to come out of here. One of the next thing that will come out, it will be this bolt up in here, which connects the bungee arm to the gear itself. You'll notice it's a pretty good sized bolt, lengthwise. And we'll pull the actuating arm out itself. It says here in fine print. Okay, best laid plans of mice and men. When we went to try and pull this arm out, we found that it was not only held in place by the 2 securing bolts, or actually studs, but also by a little bit of what we're going to figure is corrosion. We'll pull that out and we'll know in a minute. But we ended up having to pull these 2 bolts out. Again, I say bolts because they've got a bolt head. They do go into the strut housing. They have safety wire just going around looping them in place because these are actually what this connects to. And as you can see the slit here and here, those pins ride down in here. Okay, with the fore and aft trunnion disconnected and that particular assembly out, this whole arm right now moves, as you can see. What I'm going to do is raise the rear portion up and out of its cradle, drop it down, rotate the gear, and the gear will come out. And again, remember I said I like the wheel on? That's another reason why. That gives me what I need to play with it the whole time I'm moving it around. And of course, here comes the gear. Now this particular web does not have that bolt assembly on it. This is the only one that does. All right, last but not least, this is the pivot that everybody needs to look at about every 1,000 hours to make sure that it isn't damaged. One of the specific things you want to do is anytime you're doing an emergency gear extension on the ground, is do not release the gear, because what happens is all of that pressure coming down takes this and tries to rip it out of that frame, and that's what damages it. So, and the only way to check it to make sure it's in good condition is to pull this assembly out. Now, of course, you don't have to tear out the gear leg to do this, but in this particular instance where we're doing 1,000 hour, this was the easiest way to do it, and it gives us access to it almost immediately. And it'll come out just like that. And this is what this assembly looks like. And of course, what you're looking at is how much side play do you have, and once we pull it out, you send it out, and you have it magnafluxed and die penned and checked and certified that it's still in good shape.
Okay, we've got the nose of the airplane off. We've got the canvas cover off. I just thought I would show you, whenever you convert over from generators to alternators, the usual practice is to make up a separate plate here, held on with standoffs and 5 bolts, and then you mount all of your equipment on the sub panel. During the inspection of the nose gear, George mentioned the steering rollers. In paragraph 7-13 of the service manual, it talks about having the rollers moving against the steering arm. Right now, George is going to check that gap, and he's got an 8/1000 feeler, and it just goes. When the gap is larger, you're going to need to make up some rollers. In the parts manual, there are only 5 different sizes available. If the new size doesn't fit and take up this slop and tolerance. Service manual, paragraph 7-13, they describe there are 5 different roller sizes. If you put a shim in to take up the difference between the roller and the steering arm, and it doesn't fit within the diameters involved, you may have to make up some new rollers. And let me show you how that's done. I've made up an example problem here to show you the new roller diameters. You take a micrometer and you measure each roller diameter. Diameter 1, diameter 2 for each of the rollers. Then you determine what shim thickness you need to take up all of the tolerance. And that will be your new roller diameter. An example problem. Let's assume we've measured the 2 rollers at 0.850 diameter, 0.875, and we had to use a 30/1000 shim to take up the gap. You take each of the roller diameters, divide by 2, and take half the shim thickness. And for this example problem, we would machine some new rollers to 0.878. What you would probably do is buy some 4130 bar stock from Aircraft Spruce and go to a machine shop with one of your existing rollers and say, duplicate this, except make 2 of them with this new diameter. When that's done, there will be no further gap between your rollers and your steering arm.
All right, once again, we've sort of jumped ahead of everything. We're still doing it in accordance with paragraph 7-9. And to get to the point we're at right now, we followed the different steps. So what I want to do now is indicate where a lot of these items are. One of the reasons that they specify partially retracting the gear is so that you can pull this out. And if you'll notice, it's a countersunk item, and it's got a bolt on it, and this is actually what attaches the push-pull rod down in here to your retract link arm, and that of course is what draws the gear out of the way. Now another thing we've done is we went ahead and we have taken out, according to the manual, the retract links for the nose gear, and we're going to put that aside. Next thing we did was we went in and we loosened up all of the attaching fittings so that when we go to pull it out, of course, it'll come out of there easily. We also disconnected the down lock switch for the nose gear, and we're going to rest that out of the way also. And then anything else that would normally be attached to the nose gear assembly, we've disconnected or are going to disconnect. Now we've already disconnected it, and that is the electrical right here for the landing light that we've got installed. So other than that, nothing else is holding this component in that other than these 4 bolts. We did in fact pull the 2 springs that are assist springs to down lock the gear. We pulled those, and now when we pull these out, when we pull these 2 bolts out, the down lock assembly will fall down to where the nose gear will be hanging strictly by nothing more than the trunnion. There's that. This would naturally swing down out of the way, which is a good thing. Notice I left the wheel on still, and that's so that when we do in fact drop it down, we got a way of controlling the assembly. All right. And now we have the nose gear out and ready to continue the inspection. Okay, back to our project of putting in the retract rods for the landing gear. One of the things that you need to pay close attention to, actually a couple of them. One is that, now we've already removed one of the push-pull rods, and the other one here is waiting to go. This push-pull rod, by the way, runs over to the right gear, and this one that we've taken out runs over to the left gear. They crisscross back here right about where the, well actually just before the main spar. If you'll note, right down in this area here, there's a hole. And in that hole is where this particular cotter pin, or not cotter pin, but clevis bolt is supposed to push out. And in many different aircraft, you have different types of auto control. This particular one has a couple of servos right up in here that make it a little difficult to pull that out of there. So I've already set it all up to come out. I'll push that pin in a little bit, just enough so it's actually contacting the frame right here. I'll take a set of hemos and bring them out to where I can see what I'm after. Right there. Then I'll bring this rod back. By the way, this all moves very easily simply because there's no gear attached to it right now. Bring it around. Grasp that pin and pull it out. That way I don't lose that pin. And by the way, this pin, you want to make sure that when it goes back in, it has a washer and a cotter pin in it. Otherwise it'll back itself back out and hang up in this channel, and then you cannot get the gear down no matter what you do. So now we've disconnected that. I can pull this rod end out. Of course it's going to argue with me. Go on, let's see here. next thing we're going to do is go ahead and pull this rod end off. To do that, we need a pair of 9/16. So what we do is, we'll go ahead and break this loose. And remove the heim bearing and the lock nut. And the reason for that is there's another piece of equipment that's going to have to come off of here to be able to pull this cable free. And for that, we're going to need a special tool that is actually specified in the maintenance manual. Get this off of here. And it's figure 729. They've got a fabricated spanner wrench, and that's what this is right here. This has been built to those specifications, and this is one of the nuts that comes off the end of this cable. And you'll notice that this tool fits right down in it, just like that. Now it doesn't lock in, but it will in fact stay on there very well. And if you don't have a whole lot of room and it's very close quarters, you can come into it like this. It was done that way on both sides. And that's how you tighten these nuts up. If you try and do it in any other manner, you'll tear them all up, and then of course they're not serviceable. Now, okay, some of the things that I've indicated so far, I've been pointing to and so on. A couple of things that are relatively constant as far as this goes. When you go to pull the cables out and you go to pull those specific nuts off, you want to go ahead and cut these boots off. You aren't going to use them again with the new cables, and they will not allow these nuts to go past them. And if you're trying to move it out through these holes here, it makes it very, very difficult. Now, I've already loosened up these nuts in here on both of them. I've pulled the one cable out for clarity. This area right back in here, there is a couple of clamps that need to be removed so that you can get both of the cables out. Again, you need to open the airplane up just like it is, so you've got access to all these areas. And one of the things that the cable supplier suggests, and of course I agree with it, and that's to remove the transmission so it's out of your way and gives you more freedom to move around up in this area here. So with that being said, let's go ahead and start moving this cable out. Okay, now as you can see, we've already removed clamps and so on, gotten any obstructions out of the way that we need to, because we have to be able to maneuver these cables around. Another one of the constants that I found is the best way to do it is to drive it down through the belly of the aircraft. That's why you got these out here, obviously. And if you come through first in either end and move it down, it'll give you the flexibility that you need to go ahead and continue it on out. Okay, so as you're drawing it through, pushing it down, it'll eventually clear the airframe. And then, because it's clear, it comes out relatively easy until you've got both of your cables out and you're ready to install the new ones. Okay, now we're going to go backwards and install all of this. And the actual paperwork tells us to do it a specific manner, and we're going to attempt to do just exactly what it tells us, mainly because they put it together and they're going to be happy if it all goes together as designed. Now, what I'm doing right now is guiding it into that outer web, and you can hear I'm hitting up against the end of it. This end of the cable will come down here. I'm going to go down and get the other end of the cable and feed it up in through here. And of course we'll have to have another shot of it when I do that, because then we'll be up in this area. Alright, because we're going back in with it, it's sort of a reverse process, but while we were off screen, I went ahead and threaded this up through the belly and into place. I'm now going to put a stack up of washers and the nut that's necessary on it, so that when we put it in there we can tighten it all down and safety it. So let me move this back just a little bit. As I bring the cable in, I'm being careful to not bang the threaded portion. I've already put the outside nut on, and what I need to do now is thread that up the shaft. Okay, once you've got the nut on and you've got your washer stack in there, you finish putting the cable through. And now I'm not going to try and adjust it right now, simply because there are specifics for the length of the cables. All I'm doing now is just running this nut down to where it'll hold the cable in place while the rest of the assembly is going together. And of course this is only, right now, this is only the right hand gear leg. And I know it's coming out on the left hand side, but that's the way the cables cross over underneath each other in the spar area. Alright, now we've kind of progressed a little ways without your being here to watch, so what I'm going to do is explain what we did. First off, we took the old cables out. When you do that, you want to make sure that you are very careful of how you slide it out, simply because the structure, the supporting structure back in this area, is really quite fragile when it hasn't got all of the hardware attaching it to hold it and turn it as strong as it needs to be to support things like seats and so on and so forth. And it's really easily damaged, so you have to be careful when you slide these out. When you go to put the new ones in, per the instructions, you bring them up in here, lay them down, and you go ahead and then route the other end back through the hole that leads out into the wing. Once you've done that, and you don't even have to secure it, you just have it in place, then you move the cable in to where it belongs. You want to note right now that this left one, when it comes out, it goes to the right wing. The right one goes to the left wing. And they end up where this one, for instance, this one right here, goes over to the right gear. There's a specific setting per the manual that says that the nut back on this one you have to have 3 threads showing and only 1 thread showing on this one over here. So you go ahead and you fasten that part down, you tighten it down using the special tool. If you damage these nuts, you can't get replacements. When you pull the old cables out, you want to make sure you retain all of this hardware, because the new cable does not come with the hardware. Once you've tightened these down, and you'll see that the tool goes right down on there. Okay, now the safety wire is in the way, so I can't slide it down in all the way, but nonetheless, once you've got the new in, you will probably have to drill a hole for the safety wire. If you look right here, you'll see the safety wire, and there's safety wire there, and we went ahead and did as the manual instructs, which is drill a hole for the wire to pass through, then took it around the one edge, twisted it, took it through to the other side, and tied it up so that if these nuts try and back off, they will be held in place and they cannot back off any great length. If you do not do this, there is a possibility of these nuts vibrating loose, and if that happens, you will most probably have a landing gear collapse problem. You don't want to do that. So you want to make sure you safety these up appropriately. The book does call out, let me see here, on page 737, figure 714, it indicates right up here in sketch A, drill hole, and that's what they're telling you to do, is drill these particular holes. Next thing I did, I went ahead and reattached the motor and transmission. I reinstalled the safeties down here, and then you'll notice that when I do this, the actuator is actually coming pretty far clear of anything, any interference. That's this spring. The spring is something else that has to be installed. If you don't have it, when you release this, if you don't go all the way forward, that won't pop out, and it will make it almost, if not totally impossible, for you to put the gear back down, because you're fighting this connection right there. If that doesn't come up, you're fighting that connection, and the handle won't take it. Now, another thing that I've done, I've set the motor up and the transmission up the way the book tells you to, which is to give you about a 1/4 inch clearance between the stop and here. Once I've done that, then all of this will go together nicely. I went ahead and then attached my Heim bearings. Now these are new. These are not new ones. These were serviceable. They've been lubed and reinstalled, and right now they're clamped in place. There is a sleeve inside of the bearing itself, and what happens is when you put it in, this one over here especially, when you're putting this one in, you'll notice that the safety is on the inside, so you can see it. Well, what has to happen is you need to rotate your gear all the way around, and obviously I don't have the gear attached to it. Nonetheless, when we lube them up and put them in here, we then safety them so that they can't turn. We go ahead and, using safety wire or another method, we'll go ahead and check what they call a witness hole here to make sure that there's enough threads all the way up into the bearing to make sure that it isn't falling short. If the wire goes into the witness hole, it's short. You got to put it down in there further. You have to engage more threads. Next thing we do is, as far as the clevis bolts go, if you'll notice, this one over here comes in, and it has been safetied on the inside, as has this for the nose gear. Well, to do that, there's a hole up in here, and you have to have this totally forward, like this, to where all that lines up, and then we used hemostats. You can use mechanical fingers, any number of different ways, but that needs to come in from this side into the hole, through the Heim bearing, and then be safetied up like it is right here. The reason for that is limited clearance. There's very limited clearance right in here. Another thing you want to do is make sure that the safety is an absolute safety, because if it is not, when the gear is in the up position, if it's vibrating, that clevis bolt can actually slide out, and if it catches in here, again, you will have a gear failure, because you will not be able to get it to come down. All right, now I've got my transmission set up. I've got my Heim bearings on. I've got them safetied so that they won't go anywhere. Both of my clevis bolts have been safetied up. I've checked everything for clearance. I've safetied these nuts back here, so I'm good to go there. The next step will be to go out to the gear and to first off safety up where these cables go through the housing. Actually, it's indicated right here. I could show it to you in a picture, but that's about the best I can do. There's a support structure just the other side of the fuselage, and you put them through there, and again, using the tool, you tighten them down and safety them. We'll show you that in just a minute. Okay, basically what we've done is, as we've been going along, we've been taking parts out, getting ready to do the 1,000-hour inspection along with doing the cables that we've been putting in. So now we're getting to a point where we want to measure the clearances on an awful lot of these parts. We've cleaned them up, we've arrayed them here a little bit, we've got our technical data sitting right over here, we've got all of our tools that were necessary to do these measurements, and we're going to go ahead and proceed with that. One of the things I'd like to touch on real quick before we get started, and that is this spring right here is part of the downlock assembly on each of your main gear legs. This cam, for lack of better terms, has a bushing in it, and what's supposed to happen is when you tighten down the bolt, it's supposed to tighten down on this bushing, okay, along with everything else, and then we'll show you that later on. And then this particular part is supposed to move freely on it. Now there's a little land, you can't see it here, it's probably about 4 or 5 thousandths. Then when it's all clamped down tight, this will still spin. And you want to make sure that that does it, simply because if you don't, as the gear goes up and down, this piece is rotating back and forth. And as it does that, it can cut this spring. All right, first measurement we're going to take will be on this pivot right here. And what we're going to do is, it normally, by the way, goes right like that. But there's specific clearances for in this areas here. This particular one, we need to have anywhere from 0.373 to 0.376. That's what this particular tool here measures out. If the 376 goes through, you got to replace the bearings. If it doesn't, then you're still good to go. And if I bring this around here, and it will not go, and that one is our 376, and this one fits in there snugly. Almost not. So we know that that bushing is good, and it has a sister bushing, same dimensions, on this side. And again, ever so, it is really tight. You'll see that it'll stand up there, so that's a good bushing. So these bushings are good. Okay, as I said earlier, these parts are one and the same, which they are. This particular bolt, also, or clevis, whichever you'd like to call it, also has specific dimensions. It has a sleeve in it. That sleeve is what acts as a bearing surface for this. Now this sleeve has to have the same dimensions as this for the bolt to go through and hold. And you'll see on the go side, it slides right on there. And on the no-go side, it won't go on there. Okay? It sticks, and that's about it, but it won't go through there, which is good. So there's the go side, there's the no-go side. This bushing is good in its dimensions, internal dimensions. So the next thing we need to measure is this dimension right here. And according to our paperwork here, good is 0.4365 and bad is 0.495. Well, here's 4365, and you'll see that it goes through there, okay? And here's the 0.4395, and it won't go in there. It just begins, but it won't go all the way. So that's a good one also. So that means that the dimension in this unit is good. The two of them together fit in here and do what they're supposed to do. Okay, moving right ahead. We're still working with this A-arm piece, and the next thing we're going to measure will be up in here where normally this part here goes into it, and the book calls for 373 or 376, and that's what these are. We don't have it in a holder, but nonetheless that's what these are. This particular one is the 373, and as you can see, it goes through It's good and tight. It's not really tight that it can't go through, but snug, and that's good. And a 376, if this went in there, then these parts would be worn out and have to be replaced. And as you can see, I can't even begin to put it in there. So that means that that part is also, both of these bushings are good. Next, we'll come up here to these, and this is where the retract portion would go, the clevis bolt for the retract. And these particular bushings, according to the book, should be 429 or, I'm sorry, 0.249 or 0.252. And that's what these are. These are our go, no go. And as I put it in there, that one won't go. Don't let the color confuse you. And this one, because they're marked 352, which is too big, and it won't go. So let's go back to this one here. It's going ever so tightly. So those are good. This bushing right here goes down through there and actually rides in the Heim bearing. And it has the same dimensions. And as you can see, that's a go, and that's a no-go. So that means that that's good. I'll put that down there. This one, as you know, is where the pivot bolt goes, like that. And there's dimensions in here also. The book tells us that this is supposed to be 561 is a go. 564 should not be a go. And it's got a forward and an aft bushing. So what we'll try and do is send that right on through. And this is the 561. Wow, it's a tight, it is real tight. Let's try it this way. Still tight. It's getting started, but it won't go all the way through. And then this one is the 564. And it shouldn't even start, and it's not. So that says that that bushing's good, and that bushing's good. Well, one of the things that I'd like to make reference to once again, if I may, and that is when this assembly is put together and the gear is allowed to free fall during a emergency extend check, that's why this ends up being damaged to the point where there's actually, you have to do an inspection on it. Because it's the sudden stop, as all of this gear moving down is suddenly stopped, it puts a tremendous amount of pressure right here and here. And that's what weakens these and oftentimes may cause gear collapse. Okay, next thing we want to measure is the inside diameter of this bushing, which goes in here. And this is another part that is very, very critical on the aircraft. Obviously, they're all critical. Anyway, the book tells us that we should be going for a 373 or a 376. 376 being too large, and if it fits through here, then the bushing is worn. So we go ahead and put it on the 373, and you see it goes right on there. We put it on the 376, and it's kind of sliding on, but not really. And then there it's sliding on, but it only goes about halfway. We're probably going to replace this particular one, just because it's not at max, but it's getting close, and it doesn't make sense to put it back in the airplane. Now, one of the things I'd like to do real quick, and that's to show the relationship between all these little bits real fast. And all they've got bushings and so on. but when they're all together, they're what keep your gear from collapsing on you, and it's because of what they do when they're doing it. This piece, as I referred to earlier, goes in here, and actually, with the bolt in there, this is what retracts your gear, just like that. And that spring that I was talking about earlier goes from a point here down out to here. The next thing we want to do is go ahead and check the circumference on a lot of our bolts, make sure that they haven't worn down. These two particular bolts right here are both technically the same, they're just a different grip length and so on. So we'll go ahead and measure them first. And right now we've got that'd be like a 3/6-9/4. All right, so we go ahead and put it in the anvil there and tighten her down. And this is looking like 3/7/2, just about, which is thicker than what the minimums call for, and that's a good thing. Okay, next one, that's his brother, if you want to call it that, and we'll put it in there. Right there, and it looks like a 3/7, not quite 1. It's like a 3/7/09, real close to 3/7/1. So that's a good one also. This bolt here is the one that your Heim bearing and that retract spring or the extend spring ride on. And its dimension needs to be 0.245 to 0.249. Okay, and as we measure it, come on up, and it's reading out at about 247, and if you remember I said 245 to 249, so it's right in the center, so this is a good to go bolt. Then finally, this one here is supposed to have a diameter of 0.4365. Device to hold it so it's easier for me to manipulate what I got going on here. And as I tighten this down, set it, come back around, and I have, looks like about a 5.63. Anything from 5.61 to 5.64 is good, so that also is good in dimension. Okay, next unit we'll check will be the hind bearing in the retract bolt, and this attaches down to the landing gear. And what we'll do is we'll chuck it up in a vise, and we've got a dial indicator sitting here, and what we want to do is check end play. And as I'm moving this in and out, I'm seeing about a thousandths play end to end. So that's a good one. Okay, that takes care of end play on the hind bearing, and we established that this is a good one. Another thing we want to do is check the threads. To do that, we'll use another go, no-go gauge. It's marked go and no-go. If these threads will go in there, it's a good part. If these threads will go in there, it's a bad part. So let's try the no-go part first. Okay, and I finally got it started, and it only goes down about a turn and a half, and then it stops. And if I force it, I'll start cutting new threads in there, so I'm not going to force it. I back it out, and I'm using the go part now. Once I get it started, there it goes. You can see it just spins right on home. So this is a good one. That tells us mostly the dimensions are good in there, and that's good. And we have another go, no-go tool here, which will help determine whether or not this part is worn. Now, as a note, I'm just going to put a couple threads on this real quick, just like that. Every time your gear extends and retracts, this rotates, just like that. And that's what's causing the wear on these thread surfaces, the threaded surfaces, both inner and outer. It's just that little bit of rotation there that's making it so that these parts eventually become unsafe and allow the gear to collapse. Now, as far as this portion goes, again, it's a go, no-go. We'll go ahead and start it on there. And right now, that even wasn't even quite half a turn, and it stopped. Try the other direction. And it doesn't like it either. So that means that because those won't go down in there, that this part is not worn enough to be a real problem. But we're going to go one step further, because we happen to have the gauges here. And I'll put this in a vise so it's held in place. Okay, in the maintenance manual on page 70-20B, you'll see figure 7-8C, which actually has the chart in it that we're using to make our measurements and find out whether or not these components are proper. What we're going to do is we using our 32 thousandths gauge indicators, we are checking for 5/8 18 gauge, which is what this one is. Now, there is a difference between the singles and the twins, and that's called out for in the book. So what we'll do now is we've got the wire set in there. We'll come over with our micrometer. Okay. Get it set. Make our readings. And we kind of cheated on you a little bit. And these are the actual readings we got off of this earlier. And you'll see that over the wires we came up with 0.6330. The constant, which is given to us by a chart that came with these gauges, okay, tells us to subtract 0.04789. We do that and we came up with a pitch diameter of 0.5851, and when we refer back to our book, our tech data, it tells us that if we're between 5889 and 5764, we're good to go. And this number is obviously within those parameters, so that means the pitch gauge on this component. Now that we've measured out our main gear and set it up the way we need it, and we found a couple of bushings that we need to order up, those will be in shortly. When they come in, we'll carry on with that. On the nose gear, all we have really to show you, simply because it's already out, we can't show you the attach points inside of the fuselage. We did in fact measure them. The book calls out for a .4995 to .5015 for the front ones, and for the aft ones it calls out for a 374 minimum and a 376 maximum for those bushings. Those did measure out properly, and everything was good to go as far as that went, which is excellent. These bolts are actually the ones that go through your trunnion up in this area here, and they're the bolts that the nose gear swivels on. These particular sockets here should accept anywhere from 0.5000 to a 5025, and I just happen to have those here. This one is a 0.5, and as you can see, it slides in there very nicely. That's good. The same thing over here on this one, very nicely. And if we try and put a larger one in there, which would be if it was run out, and you can see this one is not going in there, and this one is a 525, which was our maximums. So we're good to go on that. The 0.5000 went in there, so here's the 5025, which is the maximum, and if we try and put that in, you can see it doesn't go in there, and it won't go in on this side either. So these two bushings here will work excellent with the bolts that we've already checked. Now, next thing we want to do is go to our retract, where our retract link attaches, which is here. This one should be a 0.374 and a maximum of a 0.377. And that was this one. And you'll see that goes in there. Doesn't wiggle around. That's a good fit. And here's the shouldn't go, and it doesn't, and that's good. And because these bearings are pushed in, you need to do both sides of it. And that checks out well also. So I'll put this down. Next we go to the retract links themselves. And these are really kind of a cut and dry thing. They're all about the same. And for instance, for this one, we are looking at a 0.370 to a 0.374, which is similar to what we had down there. And once again, we either have a tight go or no go. That's a no go. That one doesn't want to play here. There it is. I don't want to force them through because I don't want to damage the material. And you got to get it just aligned for it to go in there. On this end, they call for the same diameters. So now this one goes in a little bit easier. That doesn't mean it's worn, because the one that indicates it is worn will not go in there. You see these go in there and don't, so that's good. So those bushings are good, and of course this is the next step down, and these are the same size. You either can or cannot make it work, and again those do work, so that's good. That one's going too, and that's good. and that one won't. That's a good one. There we go. Now, this bolt wouldn't come out, but we were able to mic it to make sure that it was the proper size. And because it does not rotate, everything else rotates around it. For that matter, this goes down here, like this. Then it's not a problem, because we know this bushing's good. So when we mic it out, we came out with a proper diameter, both sides, so we know that all of the material down in here is good. Another thing that we decided to do, these lube bolts, which are actually down in this position here, they are at the maximum wear, just below the maximum wear. And because we had new available to us, we decided to go ahead and take those. And we're going to go ahead and trash these because they aren't usable. We had another set of bolts that are actually the pivot bolts for back in this area. And for that matter, the bigger one goes over here and the smaller one goes over here. They were right at the stage of being worn out, and we had more available to us. These were about a half a thou away from where they needed to be. So we went ahead and replaced those also. So in closing on measurements and making sure everything's the right size and so on, you've seen all the special tools, micrometers, all the different ways that we've done this. We've been following the tech data. A couple of other things that we're going to do is, for instance, these are those notorious bolts that the AD calls to have magnafluxed and die pinned, and we're going to send those out and have them done. We've cleaned them up to make it a little easier for whoever does the inspection to do so. We've also taken this one out, which is, if you look at the nose gear forks, this is a retract link attach point. This is where your push-pull rod comes through the front of the aircraft, through the firewall, and connects to this particular component. This is what takes the force and moves it up and down. And we've had reports of them failing down in here, and of course that causes a gear up situation, nose gear up. So we're going to have that inspected also. Okay, these are the gear support bearings for left and right gear. At least wise, this is one of them. And I just finished that one. And now I'm going to do this one. And what I've been doing is I've had them sitting in a heated area so that they heat soak and expand. And what I'm going to do now is take the bearing, which has been in a cold environment, and I'm going to take it a little bit further by using some freezing material here. And I will make it really cold to shrink it. Now when I go to put these together, I'm going to make sure that this hole, which is the grease hole for this particular bearing, is lined up with this fitting. Thing's hot. So there's the fitting. There's my hole. I line them up, and then I'll tap it in place. There, it sounds like pay dirt. If you look at the back of it, you'll see this. The keeper is in there. It's up against the keeper. And of course, we'll put the forward one in. By doing it this way, we have not damaged either the fitting or the bearing. And now we'll show you what it looks like when these get greased. Oftentimes when you pull them out, they've got grease all over them, and that's actually too much. So if you look down in there, you'll see how much grease is coming out. It's not pushing out of everywhere, it's just coming out right around the bearing itself. Let me move this a little bit here so you can see it. And also on the back side, you'll notice that it's just coming out around the bearing itself and not around the housing. And of course, when this is properly greased, as you roll it around, you'll see where the grease is coming right in along. And it's actually right along this area down in here. And it rotates in there like it's supposed to. So that's how those go together.
Well, we're getting near the end of doing this full-up inspection. We're going to show you a few things left, and we'll demonstrate that to you. Want to show you some bungee data that I took. We're going to install the bungees two different ways. George is doing the toe-in check right now. We'll show you how that's done. We're going to do the lift torque test. That's where we take a torque wrench and the adapter and put it on the rotating arm inside the airplane and lift the gear up to get the uplight and measure the torque. And then last, we're going to do a final inspect. So what I'm going to do next is zoom in on the data and explain it to you. I bought two new bungees, and I had some old ones from years past. So what I've done here is we've taken the rollers from the airplane, taken it onto a load test frame or Instron test machine where I work, and we stretch the bungees center to center on the rollers at 23 3/8 inches. That is the stretch length when the gear is down and locked. These are two bungees, new ones, and the load for new bungees was 258 and 263. 2/0 means they were on my airplane for 2 years and they just came off. In other words, 0 relax time. You can see there's a significant drop in the stretch of the bungee itself. 1/2 means it was on 1 year and then laid around in the hangar for 2 years. And this is 1/1. This would be 1 year on the airplane, 1 year in the hangar. The point I'm trying to make is the load significantly drops from brand new ones. The lowest number is 172 pounds. The ones that I took off just recently are at 191 pounds. This drop is 30%, and that is significant. Based on this data, where new ones are approximately 260 pounds after 2 years being on the airplane, 191 pounds, you need to keep in mind that these bungees help keep the gear down and locked, as well as help hold it up in the airplane when it's retracted. It would be my suggestion and recommendation that you replace bungees every year. What we have here is the bungee tool that's shown in the tip special. This end, of course, goes inside the wing at the far end and threads in. This end here has the roller, which goes on the arm, the gear arm. The stretch length is 23 3/8 inches center to center. And the way it works is you put the roller on each end after the tool is fabricated. I use tie wraps to keep it from falling off, to keep the roller centered. And then little by little, you turn this nut, quarter turn at a time. Starts out at about here, and you work your way out to here. And you just take measurements to get you to the right length. George is going to install this, and what happens is the whole unit goes inside the airplane, it gets threaded in place, and then eventually this bolt will screw into the aft gear arm on the gear. There's also another way to do it, and George will demonstrate this as well. This is a tire iron that would be associated with scissor jacks on a car or something like that. He'll show you how to put the bungees in a very simple manner. And lastly, this is the tool that I fabricated. The information is on the Comanche Flyer website. This is the tool that would go into the socket on the rotating arm at the gear motor. A torque wrench goes here, and then you rotate the whole unit, measuring the torque until you get a gear up light. Fairly easy part to make. It's 4130 steel. I used a 3/8 drive 8-point socket, 1/2 inch. That means I can put a 3/8 torque wrench in on this side or a 1/2 inch torque wrench on this side.
Okay, another thing you want to pay attention to, and we've been finding this out, and that is that as you go along and do the 1,000-hour inspection on the gear and or replace these cables up in here to set up your retract system and so on, stuff shifts, and we found that it shifts more dramatically than we had originally expected. That being said, what we ended up doing was check the alignment of the mains so that when you're on the ground and taxiing, you don't tear up tires and you don't tear up any of your supporting structures. So what we did was, if you look in the manual, it tells you to set up these big long boards and all of these different ways of doing it. Well, we found a way that was a little bit simpler than that. And what I did was I took a snap line, which will put a line down wherever I want it. I snapped the line. If you look right over here, you'll see there's an X right there. I snapped the line from the nose to the tail to give me that center line. Then I went ahead and came out to the wheels, and using a homemade plumb bob, like this one right here, I went ahead and hung it off the back end of the tire so I have another known. By doing that, I was able to then take my snap line once again and snap a line from the back of this tire to the back of that tire. And actually I went a little further out because I knew what I was going to do next, which is to use a straight edge and a T to align a wheel. Well, in the book, it also shows that this is supposed to be up here so many inches and all that. Well, we decided to go simple with it, and we took 2x4 sections, and I lay them right at the line. I take my carpenter's rule and I put it right at the line, and then I take my T and I go ahead and put it right on top of that carpenter's rule, and I move it in until it contacts the tire. And if there's no distance on this end versus this end, this wheel is in a line. We had to make adjustments, and now it is, and I have already done the same to the other. But these are things that you want to check, because once you put all of this new equipment in your aircraft, you want to keep it as new as possible, just as long as you can. As I said earlier, one of the things that we have found is that things have a tendency to shift. One of those things was this particular unit right here, which is the retract rod link assembly for the nose gear. When we went to set this in the way it's supposed to be set up, I found that this particular setting, if you look, you'll see there's looks like about 4 threads showing that weren't showing before. That means that this particular rod end was set and it was pulling so hard by 4 threads worth of material, and it would not align, and actually was putting an awful lot of stress in this area right here. So, one of the problems with trying to cut corners, and that's why we're stressing do not do that, is that if when you get to this point you say, gosh, I know my aircraft has never been gear upped, and so that is not a problem. I've done 2 of these now, and both of them needed adjustment after the fact. So yes, by all means, make sure that you check all of your distances and have that all set up. Now, one of the things that we did, luckily enough, we have examples to show you, and this particular clevis is the one that we were just talking about. And this area right in here is actually where all of your stress goes when it's trying to retract or extend the gear. When it's trying to retract or extend a gear, it's actually pulling this way. When it's trying to retract the gear itself, it's pushing, which is, and again, it all puts it pivotally right there. All right? This one right here is one of the 2 that are involved in AD note 970101 Rev 1. And this happens to be a brand new one. What we did was when we pulled these units out, we pulled all 3 out, we sent them out to a company and actually had them dye penned, and they used a wet fluorescent magnetic particle inspection and a MagnaFlux DCAC yoke with MagnaGlow, and it was visual. And it satisfies the AD note, tells us that the units that we put back in the aircraft are airworthy, and we now have a paper trail to follow if need be. All of these things are extremely important simply because these are very expensive parts, and if you don't have a paper trail telling you where you got it from, there may be a problem should anything ever happen. Okay, now what we're going to do is we're going to show at least where and how Hans's machine works, simply because for you to wait for, let's say, probably about half an hour to wind this all the way down and hook it up, takes up an awful lot of everybody's time. So what I'll do is, let me explain something going on here. You'll notice that this nut or this bolt is actually captive in this bracket. When you use this assembly and you put it all in there, this assembly is what turns that bolt. So when you put it up in the wing like this, it'll go up in to where it then will contact the area where the hole is for it to go in place. And of course then, once you get it up in there, you will turn it similar to this until it finally bottoms out. Once it bottoms out, you'll bring it back to where this bolt, either this way or the other way, will align with the hole up in the bungee arm for the gear. And then, as Hans was saying earlier, you retract this down to where you can put that bolt in, and because it's a self-locking bolt and nut assembly, you run it down tight, and then you back the machine the rest of the way out, and you cut these tie wraps, and then the unit itself will come out, leaving the bungee in place. Okay, now what we're going to do is show you my method, which is legal. It's a little different, but legal. What we did was we went ahead and retracted the gear because it places the bungee arm in a different location and allows for me to use this particular tool. And what I do is hook forward or towards the outboard end, I bring it in, I thread it onto the bungee, I hook it onto the roller, and as I move it along, I'm moving the bungee up on there. The bungee will finally take over on its own and go up into position. Then I take a rounded screwdriver, obviously, not the end, but the shaft itself is round, and I can put it up in here and walk the bungee over onto the roller. It's over center, and the bungee's up onto the roller. I can then start taking my tool and tools, plural, out. There's the screwdriver. And then go ahead. Okay, one of the reasons I was flailing around the way I was, this is not an absolute. What it does absolutely do is hook onto the roller here, and it will absolutely move the bungee for us once we get it in place, which is, it will be like this. The bungee, the hook is actually around here. Then what happens is you have to walk the bungee off of the hook, then bring the hook back around this way and have it come out. And that's what I was using the screwdriver for. And because of limited mobility up in here, perhaps a smaller screwdriver would have worked better, but for this particular instance, that's what happened, and that's why it took so long. Okay, what we're doing now is the landing gear retraction torque check. And we've got 2 torque wrenches in here simply because it makes it easier to hold the system up. We've disconnected the gear. As you can see, the transmission standing here. I'm going to turn on the master. We've pulled the circuit breaker for the motor so that the motor's not going to try and run at all. We've selected gear up, and we're looking for a yellow light to come on when we reach a specific torque rate. Now again, that's why I've got 2 torque wrenches in here. I'm going to go ahead and take the load on the beam torque wrench, and then I'll take the other torque wrench out, and when we get that light, I'll be able to read here what the torque is. That's about 110. And I think that's our max allowable. And so that you can see the light coming on if you didn't catch it last time, while I pull back on this torque wrench, it makes the switch and turns the light on. As soon as I release that pressure, that switch, and this is your up lock switch for the system. This is the whole shooting match right here. As soon as that lets go, you lose the light.
Well, there you have it. We have completed the 1,000 hour gear AD. It's been a lot of work. To give you an idea of cost and expenses here, I've added everything up, and it looks like I've got about $1,700 worth of parts in here. It's rubber booties, the bushings, the conduit, the big rod ends, the small rod ends, the spherical bearings, bungee, special bolts, springs, and miscellaneous. The NDT costs $125. So if you're going to do this, you should probably anticipate anywhere from $1,500 to $2,500 depending on the condition of your gear. In terms of labor, I've been keeping track of it. Because of the filming, it went a little slower. I've added up my hours where I was physically doing some work, predominantly cleaning parts, chasing down parts, doing the painting and cleaning up on everything. I've got 34 hours into the job. George has got 57 hours into the job. So that gives you an idea. Your mechanic may take less, like I said, because of the filming. You have anything to say, George?
No, well, yes and no. One of the most important parts of the aircraft is the pilot, and you want to make sure that the pilot gets up and down all right. And to do that, you need to make sure that your gear is going to do what you'd expect it to do. When we did this particular session, and I have another twin Comanche that I maintain, when I did that one also, I did everything by the book. And even if the parts were within limits, if we had spare parts to use that were FAA, PMA, we put those in there to make sure that we don't ever have to do this again. You want to make sure that when you come down and you land, you're not going to have your gear collapse on you. We have heard that there's been an increase in nose gear collapses. That's that clevis bolt. The clevis bolt is probably in good shape, but you may very well have too much tension on the retract rod. And these are things that you want to have your mechanic check. Without this type of a in-depth inspection, and it only takes one time every, like it says, 1,000 hours, if you don't have it, it could cause problems and you need to be careful.
Thank you very much.